So we are asked to solve for the area of this, triangle here, okay? But we're going to use what? We're going to use classical method and we're going to use integral method because remember, the integral also does what? It helps to find the area under the curve of a function. All right? So that's why we're going to use this one as well. So we're getting into new territories, ladies and gentlemen. We're loving it, right? Let's go for it. So we have the area here of this triangle here. So we have the y-axis, x-axis, 0 to 1, 0 to 1. Okay? So the area is what? Is 1 over 2 times the base times the height. Classical method, straight up, we're good, right? That means what? So that means we're getting 1 over 2 times the base, which is 0 to 1, which is 1, times the height, which is 0 to 1, which is 1 as well as a unit, right? So is 1 times 1 is 1, times 1 is 1, so it's 1 over 2 at the bottom. So the first one, ladies and gentlemen, we are finished. Okay, how sweet, right? So let's go for the second one here. Now, we have the same thing. The function is what? 1 minus x, right? The function of this line here is 1 minus x. That's a straight line. So we can always try to do it on our own to see how we can get that one. So now let's go for it. So now we got to find the area also by using the integral. So integral from 0 to 1, because here is 0 to 1, okay? That's the interval that's given to us of what? Of the function, f of x. Then we have dx. Let's go for it. So this is 0 to 1, then fx is what? Is 1 minus x. Put them in parentheses, then the dx. So I just replace f of x by the corresponding function, which is 1 minus x. Right now we got to find the integral of 1, the integral of x. And those are simple ones, okay? So the integral of 1 is what? Is x. And then the integral of x, so that's minus, is x to the second power over 2. Okay? All right, by using the formula, so we have 0 to 1 here. So by using the formula for integral, which is what? So that you have x power n plus 1 over n plus 1. Okay? So that's the formula that we just used here. All right? So that's 1 invisible 1 plus 1 is 2, and then 1 plus 1 is 2 at the bottom, and that's it. So now we can apply now the 1 and then apply the 0, so the intervals, right? The interval that we have. So the first one, 1 takes the place of x, so that gives you 1 minus. So 1 takes the place of 1, then square over 2. Okay? Then that is minus 0 takes the place of x, that's 0. And then 0 takes the place of 0 to the second power over 2. Simple as that. All right? So we continue to finish with it now. So that will give us what? 1 minus 1 to the second power is still 1 over 2. Okay? So it doesn't change. Minus 0, 0 across, so that gives just 0. So it's just minus 0. Okay? So what is 1 minus half? You take away half from 1. Simple as that. You have what? Half left. Don't think too much. All right? So this is 1 over 2 minus 0, which is just 1 over 2. So the area in this case also is 1 over 2. I'm sure if you are asked to choose which one you're going to use, you're always going to choose this one. However, understand something. The integral gives you the area of functions that you have not even dreamt about. Okay? Like the most difficult ones that we're going to see, you can use the integral for it. But it's going to be difficult to use the classical method for it. All right? So let's go. Thank you. Voila.